Hello friends, we are discussing representation of AC signals. In the previous video, we have seen two different ways of representing AC signal, peak value and peak to peak value. If you have not seen that video, the link is available in the description. Okay. Now today we will discuss third type of AC signal, representation of AC signal, that is called as average value. Okay. So friends, next value is average value and it is indicated by this VAV. If it is voltage, then VAV. If it is current, then it is IAV. Okay. So friends, average value is basically average of all the values of signal over a period of time. Means your signal is spanning from some 0 degrees to some XYZ degrees. Then you have to, in between them, you are having different values. So you have to take average of all those values. And the value which we are getting after that is nothing but average value. Okay. So if you want to write formula for average value, then it becomes average value is equal to area of the waveform, whatever area your waveform is having upon time period of that waveform. Okay. Now your waveform can be a symmetrical waveform. Okay. Just like we have seen the sine wave, which is having equal positive half cycle and negative half cycle. So that is symmetrical waveform. Or sometimes it may not be the case. Suppose you are having half wave rectifier output. So in that case you are getting positive half cycle, then no negative half cycle, then again positive half cycle. Okay. Or if you are taking output of full wave rectifier, then it is having positive half cycle and then negative half cycle is again converted into positive half cycle. So in that case you can use this average value. Okay. So we will basically divide this average value into two parts. So first we will calculate this average value for symmetrical waveform. Okay. For symmetrical wave. So I am taking example of above sine wave. So I am pasting that waveform over here. So friends, here you are having symmetrical waveform. If you look at this waveform, what you will find out, the area of positive half cycle is exactly similar to the area of negative half cycle. Okay. So friends, you have to remember one thing. If you are having symmetrical waveform, then you have to calculate average value only for any one of the half cycle. Because what happens if you calculate the average value for complete cycle, what happens? Positive area is exactly equal to negative area, and if you take average of them, what will happen? Positive area will cancel out negative area and then your average value becomes 0. So you have to do remember that symmetrical wave, for symmetrical wave, average value is always calculated for any one of the half cycle, either positive half cycle or negative half cycle. Okay. So friends, therefore here our average value is equal to what? Again, our basic formula is area upon time, but here now we will consider only area for half cycle. Okay. So your formula becomes, so your formula is modified like this. Our basic formula is what? Area upon time. So now we are for symmetrical waveform, you are taking only one of the half cycle. So your average value becomes area of one half cycle, any half cycle, positive half cycle or negative half cycle, divided by period or time of that one half cycle. Okay. So friends, what we have to do, suppose we are considering positive half cycle, then what we have to do, we have to calculate the area of this positive half cycle. Okay. And we have to divide that area by time period. So what is the time period of this positive half cycle? It is pi degrees. Okay. Pi radians, sorry. Okay. So what you will do, you will calculate this area of this positive half cycle and you will divide that area with pi radians. Okay. So then you will get the average value of this waveform. Okay. Now how to calculate the area of one half cycle, that we will see later. So first of all we will discuss how we can calculate this average value if you are having unsymmetrical waveform. Okay. Now what do you mean by unsymmetrical waveform? Suppose positive half cycle, area of positive half cycle is not equal to negative half cycle, then we can say that it is a unsymmetrical waveform. Okay. So the most frequent example of unsymmetrical waveform is half wave rectifier output. So friends, what you are getting in half wave rectifier, you are getting positive half cycle, then negative half cycle is absent, and then again positive half cycle. So in that case, what you will find out, only positive half cycle is present, negative half cycle is absent. So such kind of waveform is nothing but unsymmetrical waveform. Okay. So next we will calculate for unsymmetrical waveform. So friend, this is your half wave rectifier output. So what you will find out here, only positive half cycle is present, no negative half cycle. Okay. So area of positive half cycle is obviously not equal to negative half cycle. So this is one example of unsymmetrical wave. Okay. So now we want to calculate average value for this. So friends, your average value is again the same formula. You have to take area. Okay. But now since positive half cycle is not equal to negative half cycle, you have to consider both half cycles. Okay. So area of one complete cycle. Okay. So here we have taken half cycle, right? Now here we have to take one complete cycle, or one cycle we can write. Okay. So here we are considering one complete cycle. Okay. Then it is divided by time period of one cycle. Okay. So period of one cycle. Period of one cycle. So you have to take area of one cycle and you have to divide it with period of that one complete cycle. So this is nothing but the average value for unsymmetrical wave. So what is the difference? In symmetrical wave, you are taking area of half cycle upon time period of half cycle. Now you are taking area of complete cycle upon period of that complete cycle. Okay, so this is nothing but your average value for unsymmetrical wave. Now our aim is, now we know the area. So here what is the area? So here what is the area? That area we will calculate later. But here what is the time period? Here time period of one half cycle is pi degrees. Okay. And here area we will calculate later. What is your period for one cycle? 2 pi. Okay. So now we will calculate what is the area for this. So we know that for calculating the area of any sinusoidal waveform, you have to use integration. Okay. So friends, we know what is the equation of voltage. V is equal to Vm sine of omega t. Okay. For simplicity, we are putting omega t is equal to theta. So your equation becomes Vm sine of theta. Okay. For simplicity, we are replacing omega t with theta. Okay. Now we have to calculate this area. Okay. So what is area? So friends, area of this half cycle is calculated by taking integration. Okay. So suppose you are calculating area for half cycle. Now you know that your half cycle is starting from 0 radian and it is ending at pi radian. So your starting limit is 0 and your ending limit is pi. Okay. And what is your waveform? V. Okay. So this is your waveform. You are using voltage waveform. So V and your voltage contains theta term. So you have to integrate with d theta. Okay. Now put this equation, what you are getting. So integration 0 to pi Vm sin theta d theta. Okay. Now solve this, what you are getting. So Vm is constant quantity, take outside, what you are getting, integration of sin theta d theta. So integration of sin is nothing but minus cos theta. Okay. And what are your limits? 0 to pi. Okay. Now put these limits in this theta. We will get the final equation. So what is this? Vm. Okay. If you take this minus sign outside, so what you are getting? Minus Vm. Okay. And then in bracket what you are getting? Put the limits. Cos pi minus cos 0. Okay. So friends, what you are getting? Minus Vm, and now cos of pi means cos of 180 is nothing but minus 1, minus cos 0 is again 1. So what you are getting? Minus 1 becomes minus 2, minus 2 multiplied by Vm. So what you are getting? Plus twice Vm. So this is nothing but the area of half cycle. This is the area of half cycle. Now you have to put this area of half cycle in the above equation. So what you are getting? So friends, now you are having the area of half cycle. Okay, so what you are doing, you are putting that plus twice Vm here divided by pi. Now pi is 3.14, so 2 Vm divided by 3.14. If you calculate this, what you will get, your average value will become what? Your average value is nothing but 0.637 multiplied by Vm. Okay, or what we can write, it is equal to, if we write this in percentage, what you will get, 63 multiplied by 100. So what you are getting, 63.7% of Vm. Okay, so what is your average value? Basically it is 63 or roughly 64% of peak value. Okay, what is Vm? Maximum value or peak value. So if you know the peak value, calculate 63.7% of that peak value, you will get the average value for symmetrical waveform. Okay, so this is nothing but your average value. Okay, so how you can simply, you have to remember what is your average value. Your average value is nothing but 0.637 multiplied by peak value or maximum value. Okay, in this way you can calculate average value for any symmetrical waveform. Okay, so friends, again you have to remember one thing, whatever average value we have calculated, it is only for what? One half cycle. Okay, so this average value is applicable only for this half cycle. If you calculate this for full cycle, what you will get? Zero value, because positive area is exactly equal to negative area. So they will cancel out each other, and what is your average value in that case? It will become 0. Okay, so when you are using symmetrical waveform, you have to remember that average value is calculated only for one half cycle, not for complete cycle. Okay, now our next value is RMS value. Now why we are using RMS value? Because in most of the cases our signal is what? Symmetrical signal. Okay, our signal is what? Symmetrical signal. Okay, if your signal is symmetrical, then you cannot use average value, because average value for symmetrical signal is 0. So in that case we can use RMS value. So our last type of representation of AC signal is RMS. So friends, this is about the average value of AC signal, how we can represent AC signal in the form of average value. Okay, now next type is RMS signal or RMS representation. So we will cover that part in the next lecture. So thank you very much for watching this lecture. If you are having any doubts or difficulties, please ask me, and if you really like this video, please press the like button. Thank you very much. Have a nice day.